queuing theory. Under queuing theory, let me first of all give you a quick recap on the queuing analysis. And on the queuing analysis, we say that how do we get the probability of being busy? Probability of being busy, we see that you take the arrival rate over the service rate, then probability of being idle. Probability of being idle is 1 minus probability of being busy. Then how do we get probability of having more than n items? So in this case, you take the arrival rate over the service rate raised to power n plus 1. Also, the probability of having exactly n items. So this was probability of having more than, this was having exactly n item. So take arrival rate over the service rate raised to power n, and then you multiply by the probability of being idle, 1 minus arrival rate over the service rate. Then how do we get the waiting time in the system? Waiting time in the system, we say it's 1 service rate minus the arrival rate. How do we get the waiting time in the queue? To get the waiting time in the queue, we said it's lambda service rate minus the arrival rate. And then how do we get items in the system? To get the item in the system, so you take the arrival rate, service rate minus the arrival rate. And to get the item in the queuing system or the item in the queue, say that you take arrival rate squared, service rate minus the arrival rate. So that's how you're doing the queuing analysis. Then we also say that we have costs associated with queuing, costs associated with queuing, and we say that they are classified into two. Number one, we had the service cost, and we say that the service cost is the cost incurred by the service provider. So this one is the cost incurred by the service provider. Then number two, we have what we call the waiting cost. And we see that the waiting cost is the cost incurred by the client as a result of waiting. So this one is incurred by the client. It's what we call the benefit foregone. And we say that to get the waiting cost, you take the relevant waiting time, you multiply by the relevant duration, you multiply by the arrival rate, you multiply by the lost goodwill or opportunity cost. Opportunity cost, also known as the lost goodwill. Yeah, remember I said that the relevant waiting time, it can either be waiting time in the system or the waiting time in the queue. And then we say the relevant duration is the number of hours that that entity operates in a day. Yeah, for example, if it's operated between 8 to 5, so that's 8 hours. Then the arrival rate and the opportunity cost. So in case you missed that, so you can take a screenshot of that before we do some illustration from the past papers. So you can open with me this question. December 2010, question 4C. December 2010, question 4C. December 2010, question 4C. So first of all, we need to get the service rate, and then we need to get the arrival rate. And we are told that Dr. Rosemary Meno, a dentist, operates a dental clinic in the city center. Patient arrive at the clinic at the mean rate of 20 patients per hour. So the arrival rate is 20 patients per hour. I remember we said that the service rate and the arrival rate should always be expressed per hour. The consultation period taken by Dr. Rosemary Meno per patient is an average of 2 minutes. So the service rate, the consultation per client is 2 minutes. So can we get the service rate per hour? If one client is served for 2 minutes, in 1 hour, which has 60 minutes, so that means how much will be the service rate? So you just take 60, you divide by 2, and the service rate per hour is 30 clients. Good. Each patient is allowed only 1 consultation per day. Required. The average number of patients in the queuing system. Average number of patients in the queuing system. So that's the item in the system. And how do we get the item in the system? To get the item in system is lambda square. And in this case, our lambda, which is the arrival rate, you take 20 square, you divide by U, which is 30, 30 minus 20. In that case, you take 400, 400 divided by 3. So 4 over 3, you get 1.3. It's approximately 2 clients. That's number 1. Let's go to number 2. Number 2, the average number of patients in the queue. Average number of patients. So in the queue. So that's the item in the queue. Sorry. So this is wrong. Sorry for that. So for the item in the system, supposed to be lambda U minus lambda. Item in the queue, so we are supposed to get lambda squared mu U minus lambda. So for the item in the system, it's 20. You divide by the service rate, which is 30 minus 20. That's 20 over 10, and you'll get 2. Here we had 20 squared, 30, 30 minus 20. You're getting 1.33. It's approximately 2 clients. Lastly, number 3. The probability that is there is no patient in the queuing system. Probability there is no patient in the queuing system. So that means if there is no patient in the queuing system, that's probability of being idle. So probability of being idle. How do we get the probability of being idle? It's 1 minus lambda over U, it's 1. Arrival rate is 20 over 30. So 2 over 3, that's probability of being busy. 1 minus answer, you get 0.33. 0.33. So let's do November 2019. November 2019, question 2D. So you get the service rate, you get the arrival rate. So kindly make sure you're not copying. First of all, I'll give you time to take a screenshot. So you're told that a bank teller can open a new account at an average of 3 accounts per hour. If you can open 3 accounts, that's the service rate. That means the service rate is 3 accounts per hour. Customer requiring to open an account arrive at an average of 2 customers per hour, and the arrival rate is 2. And then the management of the bank has established a single channel, single phase queuing system. Number 1, the average number of customer in the system. Number of customer in the system. So the number of customer in the system, that's the item in the system. And the item in the system is lambda U minus lambda. So lambda is 2 over the service rate, which is 3 minus 2, and it will get 2. 2 customers. Then number two, we are told that the average time spent by the customer in the system. So in this case, they're talking about time and the average time spent by a customer in the system. That's the waiting time in the system, which is 1 service rate minus the arrival rate, and it's 1. The service rate was 3. So you take 3 minus 2. 3 minus 2, and you'll get 1 hour, or you multiply by 60, which is the same as 60 minutes. Number 3, the average number of customer in the queuing. When you talk about the number of customer, we are talking about the item in the queue. So items in the queue, it's lambda square u minus lambda. So our lambda or the arrival rate was 2, then you square, or the service rate, which is 3 minus 2. So that's 4 over 3. You get 1.33, it's approximately 2. Yeah, for the number of items, for peoples and units, you don't round off, you round up. Number 4, that's number 4. The utilization factor of the service utility, utilization factor. We say that utilization factor, it's also what we call the probability of being busy. It's also known as the traffic intensity. Yeah, it's the same as the traffic intensity or the probability of being busy. But in this case, you take arrival rate over the service rate. So which is 2 over 3. 2 over 3, that one you get 0.75 or 63. Sorry, not 2.3, but 2.67. Now, before you copy, you can open another question. So we can try another question. So you can open this question. May 2014, question 3A. May 2014, question 3A. So we get the service rate and the arrival rate. And we are told that a sales ready at a chemist outlet can serve on average of 10 customers per hour. So the service rate is 10. The arrival rate of customer average at 8. Can you indicate that? We have that past paper, it's not that clear. So the arrival rate of customer average at 8 customers per hour. So the arrival rate is 8. And remember, we said that one of the assumptions of queuing analysis is that the service rate should always be greater than the arrival rate. Then we are told that the chemists operate 15 hours daily. Now that's what we call the relevant duration. And the cost of each hour lost is 50. That's what we call the lost goodwill or the opportunity cost. Required, the average waiting cost per day. Average waiting cost per day. So how do we get the waiting cost? So that to get the waiting cost, you take the relevant waiting time, you multiply by the relevant duration, you multiply by the arrival rate, you multiply by the lost goodwill. So a relevant waiting time is the waiting time in the system. We see that the waiting time in the system is the duration between once you enter to the chemist until you leave the chemist. But in this case, how do we get the waiting time in the system? It's 1 service rate minus the arrival rate. So it's 1. The service rate is 10. Arrival rate is 8. So 1 over 2, it's 0.5. So that means the average waiting cost, so our waiting cost will be relevant waiting time, which is 0.5. You multiply by relevant duration, and you're told that the chemist is open for how many hours per day? 15 hours. Then you multiply by the arrival rate, and the arrival rate was 8 per hour. And then each hour roast cost how much? 50. That's the roast good. So how much do you get? So 0.5, you multiply by 15, you multiply by 8, you multiply by 50. And you get 3,000. So that's the average waiting cost per day. Number two, the average service rate. Average, can you underline that? Service rate, the average service rate. So in this case, we have to look at the service rate. The average service rate required to maintain an average cost of 1,000 per day. Yeah. They want the service rate so that we can maintain an average service cost of 1,000. So in this case, instead of 3,000, we need to maintain how much? 1,000. So how will we get that? So number two, we're saying that to get the waiting cost, you take the relevant duration. And in this case, our relevant duration is the waiting time in the system. So which is the same as 1 service rate. Now that's what we want, because they want the service rate required to maintain an average waiting cost of 1,000 minus the arrival rate does not change, that's 8. Then the relevant duration does not change, the relevant duration remains to be 15. You multiply by the arrival rate, which is 8, and the lost goodwill, which is 50 per hour. If you add the total, should give you 1,000. So what we need here is just to substitute this. So it's 1 u minus 8. So you multiply by, so can you multiply that? So it's 15, you multiply by 8, you multiply by 50. So times 6,000 is equals to 1,000. So how do we do that? So you multiply both sides by u minus 8. You multiply both sides by u minus 8. That one and that one goes. So 6,000 is equals to, let's open the bracket, 1,000 times u get 1,000 u minus 1,000 times 8, you get 8,000. So in that, take it to the other side. So you'll have, it's 6 plus 8,000, you get 14,000. 14,000 divided by 1, you'll get 14. Okay, so in that case, for us to maintain an average waiting cost of 1,000, the service rate will have to increase from 10, and we need to serve how many clients? 14 in 1 hour. Good, so you can take a screenshot of that. Good, so let's do another question. Do another question. June 2013, question 1B. June 2013, question 1B. So hoping we are there. Now, part A of the question. Briefly explain 6 problems associated with using simple regression model to predict the time series data. Those are the limitations of simple regression. They say that the limitation, you just convert the assumptions. I'd given you 8 assumptions, and then in the notes, I already converted them into limitations. So kindly go through that. Yeah, we say that it assumes a linear trend. Also, we say that it assumes a zero mean, but in real sense, not all means should equal to 0. Also, it assumes a constant variance of 1. But practically, the variance is not constant at 1, so it keeps on changing. You're just converting the assumption into limitation. Yeah, it also assumes that independence of dependent variable. So for the independence of dependent variable, it assumes that the independence of dependent variable y. It assumes that the values of y does not influence each other. But practically, sometimes they do influence each other. So that's how you convert the assumption into limitation. Now let's do part B. That's what I wanted to do. Part B, I told that a machine service facility specializes in the repair of machines whose breakdown are in accordance to Poisson process. The cost of an idle machine hour is $250 per hour. Now that's what we call the opportunity cost or the lost goodwill. Yeah, every hour that the machine is idle, we lose $250, or we spend an additional $250. A technician services the machine at the rate of 7 per hour. So the service rate per hour, it's 7. The technician can serve the machine at an average rate of 9 machines per hour if he attend a 1-week comprehensive training at a cost of 11,000. If our mechanic or technician attends a training, now he can be able to serve 9 instead of 7. But once he attended the training at a cost of 11,000, assume the facility operates for 8 hours per day. Now the 8 hours, that's what we call the relevant duration. And a 5-day training week, the average breakdown of the machine is 5 machines per hour. The machine is breaking at the rate of 5. So that's what we call the arrival rate for queuing analysis. So arrival rate is 5. Required. Determine whether the technician should attend the training. So in this case, we need to focus on how to get the waiting cost. And we have said that to get the waiting cost, you take the relevant waiting time. And since we are dealing with facility maintenance, so we are talking about the waiting time in the system. And then you multiply by the relevant duration. You multiply by the arrival rate. You multiply by the lost goodwill or opportunity cost. So in this case, let's look at the waiting time in the system. Now, before the training, so you see that waiting time in the system is 1, service rate minus the arrival rate. So before the training, you take 1, the service rate, you are serving 7, minus the arrival rate, which is 5. And 1/2, you get 0.5. Now, after the training, that means the service rate will increase from 7 to 9, and therefore the waiting time in the system will be 1. Service rate now will be 9, but arrival rate does not change, it's 5. 1/4, you get 0.25. So now let's get the waiting cost before the training. Now, before the training, it will be, you take the relevant waiting time. Before the training was 0.5. You multiply by the relevant duration, and you're told that the facility is open for how many hours per day? 8. Then you multiply by arrival rate, which is 5. And then you multiply by the lost goodwill. Every hour lost cost facility, how much? 250. Now, what you get there is what we call the waiting cost per day. And how much is that? So that's 4. You multiply, and you get 5,000. Now that 5,000, that's what we call the waiting cost per day. Then you multiply by 5. We are told that this comprehensive training we're going to take 1 week. And 1 week has how many training days? 5. You multiply by 5. And you'll get 25,000. That's the waiting cost per week. Now, let's get the waiting cost after the training. After the training. After the training, the formula does not change. The relevant waiting time, it will be now 0.25. You multiply by relevant duration, which is 8. You multiply by the arrival rate, and the arrival rate is 5 times 250. What you get the waiting cost per day. And then the training gonna take 5 days. So what you get? So we have 0.25 multiplied by 8. And you are getting 12,500. You see what has happened? After the training, the waiting cost has reduced, but you'll have to incur what we call the service cost. The training will cost us how much? Training cost. And the training cost for 5 days will be 11,000. So that means after the training, the total cost per week will be how much? It will be 23,500. Now, can you compare? The waiting cost before the training was 25, and the cost of the training has reduced to 23,500. So now the question was required. Let's go to the required. Determine whether the technician should attend the training. Should he attend the training? Yeah, he should attend the training. Should attend the training. So you can take a screenshot of that for 1 minute. So we can try another question. November 2015. November 2015. Question 4C. November 2015, question 4C. So you can be able to answer question A. That's what we did in our last session. Explain the following terms as used in game theory. A pure strategy. So that a pure strategy is where the entity only applies the same strategy throughout. Then a saddle point. You said a saddle point is where the gain of one person is exactly equal to the loss of the other person. Then application of learning linear programming in business. We see that they are using inventory control, product mix decision, forecasting, etc. So kindly go through that. You have them in your notes. Now let's focus on part C. Part C, we are told that Quick Work Limited deals in the provision of typing services. On average, a typist of the company receives 22 letters per day for typing. That's the arrival rate. Receives 22. So, the arrival rate. The arrival rate, he receives 22 letters per day for typing. So, 22, that's the arrival rate. But we say that the arrival rate and the service rate should be expressed per hour. That's per day. Then the typist works for 8 hours in a day. So, you divide by 8 to get on average arrival rate. So, 22 divided by 8 to get approximately 2.75. Then you are told that the typist works for 8 hours a day and it takes an average of 20 minutes to type per letter. So that's the service rate. Service rate takes 20 minutes to type per letter. So what about in 1 hour? You take 60 minutes and to type one, you need 20. So that means the service rate per hour is how much? It's 3. Good. Then you're told that the company has determined that the cost of a letter waiting to be typed is 8 per hour. So that's what we call the lost goodwill opportunity cost. And the typing equipment operates at a cost. Yeah. And the typing equipment operating cost plus the salary of a typist amount to 400 per day. Now that's what we call the service cost, the cost incurred by the service provider. In an attempt to improve on the letter typing services, the company is planning to release one of the 2 models of automated typewriters to be used together with the existing typing equipment. The additional cost per day and the increase in typist efficiency of the 2 models are as given below. We have either model 1 or model 2. Additional cost per day is that increase in typist efficiency. Now, whenever there is an increase in efficiency, so that means what will change? The arrival rate will not change. The service rate is what will change. That means you can be able to type more letters in a given hour. So required, advise the company on the action that should be taken in order to minimize the daily total cost. We already know the objective. We are told that in an attempt to improve the letter typing services, the company is planning to list one of the 2 models. So that means it's either model 1 or model 2. You advise from now that perspective. So in this case, first of all, let's get the expected increase in efficiency. In this case, the service rate is 3. Also model 2, currently the service rate is 3. Now let's go to the increased typist efficiency. Model 1 will increase by how much? 50%. So you multiply by 150%. What about model 2? 75. So you multiply by 175%. Or you just take 50% of 3 and then you add 3. So that means 3 times 1.5. That means the service rate will increase to 4.5. And then 3 times 1.75 to increase to 5.25. So with that now, let's go back here. I'm not writing that formula again. That to get the waiting cost, you take the relevant waiting time. And in this case, the relevant waiting time is the waiting time in the system, which is 1 service rate over arrival rate. So in this case, it will be 1. The service rate will increase to 4.5 minus the arrival rate. Arrival rate does not change, was 2.75. For model 2, it will be 1. The service rate will increase to 5.25 minus the arrival rate of 2.75. That one is not changing. So how much is the waiting time? So 4.5 you minus 2.75, then 1 divided by the answer. So here I'm getting 0.57. Then 5.25 minus 2.75, then 1 divided by the answer, I will get 0.4. So now let's get the waiting cost. Waiting cost, we say that you take relevant waiting time, and relevant waiting time in this case is 0.57. Here we have it's 0.4. Then you multiply by relevant duration. We are told that the typists work 8 hours in a day. So you multiply by 8, you multiply by 8, then you multiply by arrival rate. Arrival rate does not change. Arrival rate was 2.75, 2.75, 2.75, and lastly you multiply by the Ross goodwill. Any letter not typed, it costs how much per hour? Yeah, 8 shillings. 8. So we get the weighting cost. So how much is the weighting cost? So 0.57 multiply by 8, multiply by 2.75, you multiply by 8. Here you have 100.32. 0.4 you multiply by 8, you multiply by 2.75, you multiply by 8, and you get 7.4. That's the weighting cost. Also, there is service cost. Service cost. So how much is the service cost? We are told that we have the existing facilities, and the existing facility, it costs how much? We are told that. That the company has determined that the cost of letter waiting to be typed is 8 per hour, and the typing equipment operating cost plus the salary of a typist amount to 400 per day. So we have the current cost of 400. Then when we hire another model, let's go to model 1. How much is the additional cost per day? 370. If we hire model 2, the additional cost per day is how much? 390. So this one will be an amount of 770, and this one will be an amount of 790. So how much will be the total cost? So this one you get 870.32, and this one you get 860.4. Then from that perspective, which model should we take? Based on the total cost. Remember, objective, you have to minimize on cost. So you should hire or lease machine model 2. Yes, and that's the end of queuing. So you can take a screenshot of that before we shift to another topic. So now let's do another topic. I propose we do one question or two questions on set theory, because set theory, it's another part that never misses. In set theory, it's all about differentiating between and or that's all. So about to differentiate between and or, you are good. Set theory. Yeah, you know how to draw the Venn diagram. We say that we have some major terminologies. We have and. They said we have or. And they say that and, if you're told that A and B, that means common. But if you're given A or B, in this case represent or. Good. So how do you do the Venn diagram? So let's go directly to a question. So open with me Was it November or May 2019? It's another question that never misses. So open with me, May 2019. May 2019. May 2019, question 1C. May 2019, question 1C. So that's how you draw a Venn diagram. We have N. We see that N presents the population, and then it always has 3 sets. Now this is what we call the Venn. Those are called the sets. And each set has its own set of elements. For example, we have A, B, C, D, E, F, G, and H. Then after we get that, we have to get A, B, C, D, E, F, G, H. Now let's read that question. We told that. A medium-sized commercial bank has a clientele of 200 active customers. N is 200. Can you underline active customers? Yeah, if you have active customer, that means all of them, they have an account. The bank operates 3 different types of account, namely current account, savings account, and fixed. They have the current account. They also have savings account, and also they have fixed deposit. Let me repeat again. We are told that a bank has 200 active customers. And then the bank operates 3 types of account. So if the 200 are active and the bank has only 3 accounts, that means H is what? H is 0, because H are individual with no account. And in this case, we are talking about the 200 active. So if they are active, that means all of them. It's either you're having a current account, you're having a savings account, you're having a fixed. You can't be missing any of the accounts. So H in this case is 0. So that was only the trick in this question. Information obtained from the bank indicates that. So then we are given all that information. So we have 84, we have 109, 106, 45, 36. Is that 43 or 13? That's 43. So let's start with the first one. Yeah, information from the bank indicates that 84 customers operate savings account. 84 operate the savings account. So you take that circle for savings account. All the members in the saving account, we have B, C, F, G. So we have B, C, F, G. Then 109 customer operates current account, So let's be here. You take all the members in the current account. We have A, B, C, D. A plus B plus C plus D. Then 106 customer operate fixed deposit account. Fixed deposit account. You take all the members in the fixed deposit account. We have C, D, E, F. C, D, E, F. Then 45 customer operate both savings account and current account. So in this case, they have used the word and. And means common. They operate both savings and current. They are in savings and also they're in current. Take the joining point. Savings, current. That's B and C. B and C. Then 36 customers operate both saving and fixed deposit. Savings and fixed deposit. So we have saving and fixed deposit. And we have C and F. So that's CF. Then lastly, 43 customers operate both fixed deposit and current. Fixed and current. They're in fixed, also they're in current, and that's C and So we have C and D. And I think that's all the information given. So now let's do the cracking of numbers. We do the cracking of numbers. How can we crack this? So in this case, we don't have any specific number known apart from H. So we need now to crack. And how do we crack? So we have BC, which is 45. BC is 45. If we have BC, that means we can be able to get F and G. And that means F plus G is equals to, you just take 84 minus 45. 84 minus 45. And you get that in? That's 9. Also, you have BC, you substitute the second equation, BC. That means you can get A and D. So A plus D is equals to, you take 109, you minus 45. And you get 64. Then you have CF, that is equation, this one, which is equals to 36. CF is equals to 36. Here we have CF. That means we can get B and G. So that means to get B and G, you just take 84, you minus 36. This is CF, and you get 48. Then the last equation we have CD. CD is equals to 43. If we have CD, use the second equation, CD. That means you can be able to get A and B. And A plus B will be, you take 109, you minus CD, which is 43. That means this one you have 66. Also CD, in the third equation you have CD. That means you can get E and F, and to get E and F, it will be 106, you minus 43, and you get 63. Still, we have not cracked any of the numbers, but you know very well that if you take A plus B plus C plus D plus E plus F plus G plus H, the total should give you how much? 200. And you know very well that H is 0. Then we have that equation CDEF. CDEF is equals to how much? 106. Then we have AB. Do we have AB? Yes, we have A plus B, which is 66. So now we are remaining with who? G. So to get G, you take 200, you raise 66, you raise 106. So it's 200, you raise 66, yes, 106. And you will get 28. Once you're able to crack only one number, now you have everything. So in that case, our G is 28. With G, you can use even the first equation. F plus G is that 9. So you take that 9, you raise G, which is 28. That means our F will be 11. F is 11. If you get F, you can get C. Are you together? So it's 36 minus 11, and you get 25. 25. So C is 25. Once you get C, BC is 45, and you already have C. C is 25. Can we get B? B is what? B is 20. Then CD is 43. We already have C. C is 25. Can we get D? Yeah, 43. You raise C, which is 25. That means D will be 18. So we are remaining with A and E. So let's get E. So let's use this equation. E plus F is 63. F is 11. That means E is 52. Now we are remaining with only A. Can we get A? Yes. A plus B is equals to 66. B is 20. That means A is 46. Now, can you try to add the total? Tell me, is it equals to 200? Yeah, you are getting 200. So once you have that, A is 46, B is 20, C 25, D 18, E is 52, F 11, G is 28, and that's 0. So now we can go back to the required. So what was the required? Required number 1, present the above information in a Venn diagram. We already have that. Let's go to number 2. Number 2, probability that a customer selected at random operate all the 3 type of account. That's automatically C, eh? Yeah, that's C. And C, we had how many clients? 25. But in this case, the examiner wants the probability. So you take 25, you divide by 200. So 25 divided by 200, you get a probability of 0.125 or 12.5%. Yeah, that's C. C is the only one operating all the 3 type of account. Number 3. The probability that a customer selected at random operate only 2 type of account. Only 2 types. Only 2 types. That's very easy. So in this case, we have B, C, D, F, but C operate 3. Are you together? So in this case, we only have B, we have D, and we have F. But the question was at least 2. That's when you could have included C. So only 2 type is only B. Then we have D, and then we have F. And B we have is 20, D we have is 18, and F we have is 11. Yeah. Probability that customers operate only 2 types. So that is that 8, you add 11, you get 40, 49, but they want a probability. So probability, you take 49, you divide by 200. The probability is 0.245. Good. So you can copy that. I mean, you can take a screenshot. Good. So there's a question I had issued for my Cat 1. That is open with me, June 2010. June 2010, question 2D. June 2010, question 2D. June 2010, question 2D. So we need to get N. So June 2010, question 2D. So you're told that a sample of 900 voters, so N is 100 voters, reveal the following information concerning their preference for candidate X, Y, and Z, who are vying for the party chairman, secretary, and treasurer position respectively. So we have candidate X, Y, Z. Then we are given that information. So we have 15, 11, 14, 37, 34, 54, 62. So you're told that 15 voters were in favor of X and Y. X and Y. We say that and means common. So X and Y, that means we have B and C. So that's B plus C. Then 11 voters were in favor of Y and Z, but not X. Y and Z. So let's be here. Y and Z. Now Y and Z, that is C and F, but not who? But not X. So to X. So is that member? That's F. Let me repeat again. Y and Z, that's C and F, but we are told that, but not X. So you eliminate X. So you already made who? F. $14 voters were in favor of Z, but not X or Y. 14 voters were in favor of Z. They're in favor of Z, but not X, not Y. So in short, those are the members in favor of Z only. And who is that? We have E. That's E. Then that 7 voters were in favor of X or Z. Can you underline or? We say that or means or. That 7 voters were in favor of X or Z, but not Y. But not Y. X or akokwa Z, that means it's all the members in X and Z, but not who? Y. So unang'oa Y vizuri, utabakia nani nani? Ng'oa Y. You only have A, D, and E. A, B, and E. That's what it meant. That 7 were in favor of X or Z, but not Y. Then 34 voters were in favor of at least 2 candidates. At least 2. So at least 2, that means we have B, C, D, and F. So we have B, C, D, and F. Then 54 voters were in favor of 1 candidate only. Only 1 candidate. That's A, E, and G. A, E, and G. And lastly, 62 voters were in favor of X or Y or abstained, but not in favor of Z. Not in favor of Z. X or Y or abstained, but not in favor of who? Not in favor of Z. So more Z vizuri. Apart from Z, who are the other members remaining? A, B, G, and H. A, B, G, and H. I think we are through with that. So now let's track the numbers. We have F. F is 11. We have E. E is 14. Which other equation can we use? So let me call it equation 1, 2, 3, 4, 5, 6, and 7. So you already have E and we have F. With E and F, we have BC. So let's use equation number 5. Let's go to equation number 5. We have BC. How much is BC? BC in equation 1 is 15. Then we have F. F is 11. So that can we be able to get D? Yes, you take 34, you minus 26. 34 minus 26, you get how much? Is it 18 or 8? 8. So D is 8. Now with D, which other equation can we use? So we have ADE. ADE. Yes. Let's go to equation number 4. Number 4, we don't have A, but we have D and we have E. So we can be able to substitute. So you take that 7, you minus D, D is 8, you minus E, E is 14. So that means A will be, so A is 15, right? A is 15. Now we have A. So let's go, let's go to equation number 6. Number 6, we have A, which is 15. We have E, which is 14. That means we can be able to get G. So you take 54, you minus A, which is 15, you minus E, which is 14. That means G is 25. So we have that. We have that. We have used that. We have that. We have that. BC, that one can't help. Now let's use equation number 7. We have A. We don't have B. We don't have, we have G. We also don't have H. So that one cannot help us. Even equation 1 cannot help us, B and C. So ikikata, you know, A plus B plus C plus D plus E plus F plus G plus H will give you how much? 100 voters. What do we have? So we have B, C, D, F. Equation number 5. B, C, D, F. B, C, D, and F is equals to 30. Yeah, that's B, C, D, F is 34. We have E is 14. We have A is 15. We have G is 25. Who is an unknown member here? H. It's only H. So to get H, you take 100, you minus 25, you minus 34, you minus 14, you minus 15. And you get H is equals to 12. So H is 12. If H is 12, now we can substitute equation number 7. Let's go to equation 7. So you take 62, you minus A is 15. You minus G is 25. We minus H, and H is 12. So the remaining member is B. That means our B is equals to 10. You only now remaining with C. Let's go to the first equation. First equation, that B plus C is equals to 15, and our B is 10. That means is 5. A 15, B is 10, C 5, D 8, E 14, F 11, G 12, and H is 12. So let's go to the required number 1. The number of voters that were in favor of all the 3 candidates, that's C. Who is that? C were 5. Number 2. Number 2. Assuming that a candidate who gets more than 50% of the votes is elected unopposed. Determine the candidate, if any, that were elected unopposed. So we had 3 candidates, X, Y, Z. So let's get all the voters who are in favor of X. So X, we had A, B, C, D. So A is 15. B we have is 10 plus 5 plus 8. Then Y, we have 10 plus 5 plus 11 plus 25. And all the member in Z, we have 5 plus 8 plus 14 plus 11. So 25 plus 13. Then we get 38. That's 15 plus 36. Get 51. Then we have 13 plus 25, you get 38. So this is percentage, percentage, percentage. So who will be elected and opposed? Y. Y has 51%. That's what they were looking for. Good. So we can take a screenshot of that. So I think now you are good with set theory. We move to another topic. let's do a bit of 1 or 2 questions on simulation. Simulation analysis. Simulation analysis. And we see that simulation analysis or simulation is just a systematic duplication of event by the use of random numbers and probabilities. And then we say that we have some steps forward when it comes to simulation. One, you identify the objective, identify the input variables, you identify, then you develop probability distribution or the Monte Carlo. And then from there, you come up with determine the logic of the model. And then you come up with a simulation sheet, as simple as that. Then kindly go through the advantages and disadvantages. Advantages and disadvantages of simulation analysis. Good. So open this question. May 2015, question 5. Sorry, May 2015, question 4C. May 2015, question 4C. May 2015, question 4C. So we are told that Mary Mombi has recently acquired a water pump, which has a useful life of 10 years. It's estimated that the pump is likely to have periodic failures over the useful life. Past data of similar pump indicate the probability distribution of failures as follows. So given the number of failures, probability required. Simulate the average annual life, annual failure rate of the pump using the random number. That's very easy. So in this case, our objective is to determine the number of failures. And then how many variables do we have? The variable we have is only one because you only have one probability. So that means you only prepare one Monte Carlo. So let's present Monte Carlo. And for the Monte Carlo, we are given the number of failures. Then you have probability. You cumulate, and then you range. So we can have 0 failure, 1, 3, or 4. We have the probability 0.75, 0.20, 0.04, 0.01. So let's cumulate the probability. This is 0.75, 0.95, 0.99, 1.00. Then raise range 0, 0. We see that when ranging, use the cumulative probability and assume they are whole numbers. So for example, the first one you assume it's 75, not 0.75. So you take 75, you minus 1, and you get 74. From 74, you go to the next number, which is 75. 95 minus 1, you get 94. 95. 99 minus 1, you get 90. 98. Then 99. 100 minus 1, you still get 90. So with that, now let's come up with simulation worksheet. Simulation worksheet. So trials, then we have the random numbers, and then we get the number of failures. It was as simple as that. So in this case, if you want to know the number of trials, use the random numbers. And random numbers, we have 65. We have 80, 30, 15, 50, 90, 52, 73, 62, 92, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As simple as that. So let's estimate the number of failure. Now the first random number is 65. So 65 lies in between 00 to 74. So now have how many failures? 0 failures. 80, the random number of 80 lies in between 75 and 94. So that means you'll be having how many failures? 1. 30 lies in between 0 to 74. So that is 0, 0, 0, 90, 1, 52, 0, 73, 0, 62, 0, 92, 1. So add the total number of failures. There are 3. That's the total. Now let's get the average. The average, you just take 3 over 10 and you get 0.03. As simple as that. So you have nothing to take a screenshot of. That one is something to remember. Kuna just screenshot. So we can still do another question. December 2012. December 2012, question 5A. December 2012, question 5A. I syndicated page 3. So question 5A, hoping we are there, that's at page 3. And you're told that Hekima Limited is in the process of launching a new product into the market. The initial cost of launch is 6 million. Then the probability distribution of the selling price, variable cost, and sales volume is as given below. So you have that selling price probability, variable cost probability, sales volume probability. So that means we have 3 variables, therefore you prepare 3 Monte Carlos. The following random numbers have been provided. So you are given all that information. Required. Average profit of Hekima Limited using Monte Carlo simulation method with 12 trials. So our objective, let's go to the required. You are told that you determine the average profit. So it's profit maximization. Then step number 2, you identify the input variables. And we have 3 variables. So number 1, we have is the selling price. We have variable cost, and also we have the sales volume. And then step number 3, you develop Monte Carlos. Monte Carlo or probability distribution. In this case, we prepare 3 Monte Carlos. The first one is for the selling price. For the selling price, you have the amount, probability, you cumulate, and then you range. So it can either be 500, 600, 700. Probability is 0.3. Now let's go to the random numbers. Let's go to the random numbers given. And for the random numbers given, you can see you are given in pairs. That means they are in hundreds. So if they are in hundreds, probability you are given is 0.3. So kindly don't write 0.3, just write 0.30. If you are given 3 random numbers, actually in pairs of 3, that means in thousands, could have been 0.300. So the other one is 0.50. The other one is 0.20. This one will be, let's cumulate 0.30, 0.80, 1.00. Then we go to the variable cost. Variable cost, the same. So we have the cost or the amount, probability, you cumulate the probability and then you range. So it's 300, 400, 500. Probability is 0.10, 50, 40. Let's cumulate 0.10, 0.60, 1.00. And lastly, we have the sales volume. For the sales volume, we have the number of units, probability, accumulate, and then you range. So we'll be having that 5,000. You can also have 40,000. So you can have 55,000 with probability of 0.20, 0.40, and 0.40 still. Then you accumulate 0.20, 0.60, 1.00. So let's range. Here we have 00. Just take that minus 1, you get 29. 30, 80 minus 1, you get 79. 80 to 99, 00 to 09, 10 to 59, 60 to 99. 00 to 19, 20 to 59, 60 to 99. Then step number 4, you determine the logic of the model. How do you determine the logic of the model? Now, in this case, our objective is to determine the profit. And then we have 3 variables. We have the selling price, variable cost, and sales volume. So when developing the simulation worksheet, how can you arrange that information so that you can attain your objective? So to get the profit, you just take the selling price, you raise the variable cost so that you get the contribution margin per unit. Then you multiply by the sales units or the number of units sold so that you get the total contribution margin. And then you raise the fixed cost. So that's how your simulation worksheet will look like. So let's develop simulation worksheet or simulation table. So we'll have the trials. We are told to perform on the basis of 12 trials. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have said that we're just following the logic of the model. You take the selling price, you raise the variable cost so that you get contribution margin per unit. And then you multiply by the sales volume. That's how you get your total contribution margin. Once you get the total contribution margin, you raise your fixed cost, and then you can get your profit. So let's take a 1-minute break. So now let's complete this. So selling price, we have prepared the Monte Carlo. So divide it into 2. One is random number and the amount. For the variable cost, you do the same, random number and determine the specific cost. Also, you have the Monte Carlo for sales volume. Therefore, you divide it by 2. One is to record the random number and the number of units. So I want to do it halfway. Let's just do it halfway. So let's start with the random number for selling price. We are given the random number, specific random number for selling price we have 44, 84, 82, 50, 85, 40, 96, 88, 16, 16, 97, 92. Then for the variable cost, you have that 9, 33, 83, 42, 16, 07, 77, 66, 50. Then for the sales volume, we have 58. Then we have 44, 77, 11, 08, 38, 87, 45. So now let's work out on that. So let's start with the selling price. I only want to do for 5 of them. So the first random number and the selling price we have is 44. So come to the random number of the selling price. Come for the ranges. 44 lies in between 30 and 79. So that means the selling price will be 600. 84 is in between 80 and 99. So that means the selling price will be 700, 82, 700, 50, 600, 85, it's 700. And then you complete that. Let's go to the variable cost. So for the variable cost, now use the Monte Carlo for the variable cost. The first random number we have is that 9. So that 9 rises in between 10 and 59. So that means the variable cost will be how much? 400. Then that 3 rises in between 10 to 59. So it's still 400. 83 rises in between 60 and 99. So that's 500. So 42 is 400. 16 it's 400. And then you complete that. Then let's go to the sales volume. Sales volume, use the Monte Carlo for the sales volume. The first random number we have is 58. 58 rises in between 20 and 59. So that means you sell 40,000 units. 44. 44 is the same, 40,000. 77, 50,000. 11, that 5. 08, 35. So with that now, let's get the profit. So we say that you take the selling price minus variable cost, you get the contribution margin per unit. 6 minus 4, you get 200. 7 minus 4, you get 300. You get 200. 6 minus 4, you get 200, and you get 300. Once you get the contribution margin per unit, you multiply by the number of units produced. 200, you multiply by 40, that's 8 million, right? 8 million. 3 times that, you get 12 million. That one, you get 10 million. Yeah, you get, is it 7 million? 7 million. And here you have what? That is 10,500. You do like that up to the 12 trials. Then you raise the fixed cost. We are told that. How much was the initial cost? Yeah, initial cost was 6. So every year deduct 6 million. Remember, these are the number of trials. They are not years. So once you take the total contribution margin minus fixed cost, you get the profit. Like in this case, you get a profit of 2 million. That one you have a profit of 6 million, a profit of 4 million, 1 million, 4.5, and then you complete until you get the totals. Once you get the total, you compute the average, and the average you take the total, you divide by the number of trial, which was 12. Good. I think that's okay now. So simulation is down. So God willing, we meet next week. And that marks the end of that session.